So now we are going to discuss about CNN. So what is the CNN? That's nothing but convolutional neural networks. So now in this section we are just going to discuss about convolutional operation and this ReLU layer, pooling, flattening and then full connection. So apart from we need to discuss about cross entropy and softmax. So what is convolutional neural network? So this is the image which we are going to observe now. So like when we are seeing this, someone will tell this image is a side face image, else this image is the thing which is facing front. So but actually this face is front face image, but the observation of this image is totally different. So this is what known as convolutional neural network. So how we observe this image, that's what our convolutional neural network is. So when we are going to observe this image, in which part, either is a side face image or it's a front face images. So when I am talking about this, someone will understand this as a side face, someone will understand this as a front face image. And one more example for CNN. So here this is for one image which is having it may looks like a girl or it may looks like a old woman. So now is it original image is girl with muffler or old woman? So this is what now question is. So some peoples will analyze this as a girl with muffler, some peoples they will analyze this as a old woman. So now what is that exact image? Now we are just going to read the image. So this is a blur image and this is the image of duck. So this blur image, which is original, like this part is original or this part is original. Now our neural network is going to analyze about image exclusively known as convolutional neural network. So some of the things. So now when we are just giving this is a cheetah. So it's a leopard or snow leopard or Egyptian cat. So this cheetah, which is, it may be the combination of any these things. So simply when I am giving this image to my network, my image may understand this as a cheetah or a leopard or snow leopard or Egyptian cat. So now which is real answer? This is my real answer. If my machine consider this as a leopard or snow or Egyptian, then it's all my prediction is wrong. So the next thing is bullet train. So this is bullet train image. Instead of bullet train, what are the other possibilities? Passenger car and a subway train and electric locomotive. So when I am just asking my neural networks to read about this image should give the right answer of bullet train. If my image is not giving the right answer of bullet train, then my accuracy score is little less. So either it's a passenger train or a subway train or electric locomotive. So we are just giving this thing and we are just asking our network to guess what is this image, and this is another image. This is, it may be a scissor or it may be a hand clasp or it may be a frying pan or it may be a stethoscope. So the answer for this is hand clasp. So now our neural network, it should understand about our image. If it's really understanding the image, then our neural network accuracy is more than 85%. So let's see how this neural network works. So now a few years back, when the convolutional neural network, by the 2012, this Google search for convolutional neural network is in less than 25, but now it slowly starts to increase, and this neural network, this ENN, is now beats our ANN. Now it's in the higher rate. So this is the search result for our ANN and this is our search result for CNN. So the average of our CNN, it's getting increase. So this is the person who's known as godfather of neural network, Ian LeCun. So this person introduced this neural network for convolutional. So how the convolutional neural network work? Where we are having an input image, we are giving this input image to this CNN, that's nothing but our convolutional neural network. This convolutional neural network will convert our image class to the output label. So this is the basic layout of our convolutional neural network. So now this is two smileys which we are going to give it to our neural network. So this is the smiley which is giving you the happy symbol, and this is the smiley which is going to give you the sad. So when we are passing the smiley to our neural network, it should understand either it's a happy or sad. So the next thing is how the convolutional neural network is working. We are having a two type of images, one is black and white and another one is colored image. So when it comes to black and white, we having a pixel 1, pixel 2, pixel 3 and a pixel 4. So 2 into 2 pixel. So this 2D array, when we are just converting, this is an another part, pixel 1, pixel 2, pixel 3 and pixel 4. So when we are handling black and white image, this image system will totally work based on 2D array, that's nothing but two dimensional array. When the colored image comes 2 into 2 pixel, the same 4 pixel of image, when we are planning to convert, we need to convert to 3 dimensional array. So what is this 3 dimensional array? That's nothing but red, green, blue. We need to make it like this, red, green, blue images. So this pixel, it comes with 0 to 255, where we need to make it into 3 dimensional to analyze our colored image. So this is our smiley. So how our convolutional neural network connects? For neural network, everything is zeros and ones. So this is our smiley image. When we are applying this to our CNN, that's nothing but our convolutional neural network. Here for this we'll be getting this one, and for this we'll be getting this, and for this box we'll be getting a box here, and this is for our happy image. So all these things in our output layer, we will be getting one for this, and here also one for this, and here also one for this center image, and here one, and here also one, and here also one and a 1. So now how it's working, looking is like our happy smiley. The same if it comes to bad, sad, we'll be getting a convolutional neural network like this. So here, here, here and here and here, it will comes as a sad smiley. So now based on this analysis only, our neural network is getting understand about how it's working. So this all the methods we need to apply in our neural network. One is convolution, another one is max pooling, another one is flattening, and another one is full connection. So this person, like gradient Besant learning applied to document recognition, which is by this Ian Lacan. This is the best documentation to refer about CNN. So convolution, subsampling, again convolution, subsampling and full connection. So this is how one CNN network looks like. So this is the formula where our convolution neural network will apply. So f into g of t define, so from minus infinitive to infinitive, f of t g t minus sigma of dt. So this is your input image which looks like this. We need to apply to the future detector. So how this is going to be work? So this image, which is nothing but our happy smiley image. So see, this is our happy smiley image. Now we need to apply and we need to convert our input image to future detector. So how the future detector work? So for this, future detector will always 3 into 3 dimension. So here 3, 3, 3 and 3. So 3 into 3 dimension, 3 row, 3 column. So this future detector will go and apply with our input image. So here this is our input image. This future detector will go and apply with this input image. So this is one part which we are having with our data. So now we are comparing this future detector with our input image. So now this is the box which we will be getting this. So 0 0 0, again 0 0 0, 0 1 0, 0 1 0, 1 0, again 0 0. So everything now it comes as 0. This is what our future map is. So the next thing is, again your future detector will go and apply the image here. So first 3, then it will start from here. So 0 1 2 3 4 5 6. So first 0 to 2, then 1 to 3, then 2 to 4, and 3 to 5, yeah, then 4 to 6, like this. So till it leads. So those detector output is your future map. So now 0 0 0 0 0 1, again 0, and 1 1 will get 1. So here we are getting 1 1, so our output will be 1. No, we are getting more than 1 1, so almost we are having 4 1, so we will be getting our future detector as 1. So the next thing is, we will be getting all the future detector output likes. So this is known as our convolution layer. So when it comes to input image, everything is considered as your input image. This is one part, and from here to here is another part, and from here to here is another part, and here to here it's another part. Like this, our input image is applied to multiple future maps. Each and every future map is applied with our input image. So the group of future map, which is known as convolutional layer. So this convolutional layer, that is nothing but group of future maps, which is be detect with our future detector. So now input imager into future detector. So each and every input image is applied with this future detect, and our final output looks like this. So this is what our future map is. So in this future map, we will be getting a output, lot of outputs. So when your blur image, when this is a blur image, how it looks like this. So blur image means everything 0. In center we used to get 1 like this. And when it comes to edge detector, the input image like this, we used to get a output looks like this, 1 -4 and 1 1 1 like this. And empose, like image which is looking like this, we will be getting an output which exactly looks like this. And the next thing is sharpen. For sharpen, -1 -1 -1 -1 5. So all this combination is our sharpen. So when you are applying this image and your future detector which comes like this, then your image maybe looks like this. This is how your convolutional will understand your image. So ReLU, that's nothing but convolution. We are going to apply our rectifier in our convolutional layer. So each and every input image is applied with your future detector, and the future detector will produce one future map output. So group of future map is your convolutional layer. So this convolutional layer we will be applying with rectifier to understand about the value between 0 to 1. So this rectifier function, which is the common like our ANN. So after this is the original image, and this original image we will be applying with our future detector, and with the rectification function your output looks like this. So here the more black, here we will be getting the more black, which consider as a negative, and this all be something which is comes like 0.5 0.7 0.8 like this. The white value which we are getting here, this all consider as a positive. So the more positive, the white, the very white one, it's considered as a 1, and a very black it's considered as a 0. The remaining gray, cyan gray, everything it comes with the range of 0 to 1. So now only we want to get the non-negative values. When you want to get only the non-negative values, that's nothing but which is not less than minus. So we will be getting a values which is 0 to 1. So this is how your ReLU works. So when we are applying the activation function in sigmoid, it will start from minus and it will end with 1. When it comes to ReLU, all minus will consider as like 0. It's actually starting from 0 and will just to go ahead. And leaky ReLU, it's again go with the negative values. So the next thing is max pooling. So max pooling, that's nothing but where we having an image like this. So little rotate and something like a square or rectangle like this images. So now whatever the image shape is, either your image looks like this or looks like this, we need to make it perfect. So now this is a various image of cheetah. So this will looks like a cat, and this is looks like again Egyptian cat like this. So we know this category, but machine it does not know. For this, when it's having a this like this, and this nose which looks like this, and the ear and the eye, so where it's having a multiple images which is already readed. So for cat it's already read 1000 images, and for cheetah again it's reading 1000 images, and for lion it's reading 1000 images. So which this shape which is actually which shape is actually similar to this image, it will give the result. That's what your machine will do. So now how this max pooling is working. So pooling, that's nothing but again the future map. There we apply 3 into 3. Here we are going to apply 2 into 1. So now here it is used to get the maximum value. So here 1 and 1, it's a 1 is your maximum value, and here also 1, and again here also 1. So then here again 0. So we will be getting the maximum value. That's what your max pooling is. Max pooling, that's nothing but 2 into 2 dimension you are applying a future map, and the maximum value in the particular future map we will be getting. That's what our max pooling is. So after we are getting this max pooling, this is our input image and our convolutional layer. Each and every convolutional layer will applied with our pooling technology. Not our input image we are applying, our convolutional layer we will be applying with our pooling. So now we are having an input image we apply to the convolutional layer. So multiple future map is your convolutional, and this convolutional again we are applying to this pooling technology. So now flattening. So flattening, that's nothing but the pooled future map. The output of our pooling thing we will be going to convert, which exactly looks like this. So 1 1 0, then 4 to 1, and 0 to 1. So this is what our flattening is. So this is an input layer which we are going to give for our ANN. So this input layer we will be applying to the convolutional. So this convolution we are applying to the pooling, and this pooling we will be converting to the flattening, and this flattening now it works like an input layer for a future ANN. So again the flattening output, it's our input layer. Again we are just giving our hidden layer, and from this we will be getting our output value. So this is what the full connection of our CNNS. So the full connection we used to get 2 outputs, either the particular image is a dog or cat. So we used to compare with the multiple outputs also, like dog, cat, lion, like what is the given image is belongs to. So for this we can able to apply our forward propagation and backward propagation both. So when we are applying a flattening, it will apply to our neural network. So our neural network will give predict and it will give the result. So this all like how, like 0.9, 1, 0.21, 0.21, 0.1, 0.1. So now we are matching this 1 and 1, which is actually connecting with the dog. It's not connecting with the cat. So for example, if we are having this 3 ones here, and 2 is connecting with the dog, and only 1 is connecting with the cat, again we will get the cat. So here if we are having 0.1, 0.9, only 0.9 we are having. So 0.9 is connected with the cat. So now cat will be our output. This is how our ANN will give. So we having an output which is in a hidden layer 0 to 1. So the more one connection, that's what our output is. So this is how our full connection will do. So here, which is very related to 1 and 1. So those value, based on those value, we are just getting our output value. So this is how our CNN work, the full connection. So simply we will be just applying the input image, applying to the convolution, that's nothing but converting to the future map. After converting to the future map, we are applying to the pooling technology. After pooling, it will convert to flattening. This flattening is the input layer for ANN. From input layer, again we are taking a multiple hidden layers. In hidden layers, we are having a values in between to 0 to 1, which is closer to 1 and which is all 1. So how many ones and how many one closer are connected to dog and cat. The more one connected, that's what our output image is. So this is how the CNN works.